this session, we are going to look at insecure direct object reference. Insecure direct object reference occurs when applications provide direct access to objects via user-supplied or user-controlled inputs. These objects or identifiers, in turn, allow access to system resources such as files, user records, databases, etc. Now, you heard me say user-supplied or user-controlled input. What is the difference between the two? User-supplied inputs are the values end users are allowed to key in the application front end. However, there are certain HTML fields that cannot be modified in the front end but can be tampered using what we call a proxy tool, which is widely used when conducting security testing. Proxy tools act like a middleman and allow you to modify inputs which cannot be sometimes modified at the front end. And such an input that is modified using a proxy tool is referred to as a user-controlled input. That is why when it comes to security of an application, it is very important to carefully validate all HTML fields to avoid security attacks. Now, we touched on proxies in one of the previous sessions. You can find a link to it above and also in the description of this video. Getting back to insecure direct object reference now. So let me give you an example. Let's look at the URL that you see in the screen. So what this really does is retrieve the user records for an authenticated user with ID 123. Now, if the application is vulnerable to insecure direct object reference, which happens due to improper authorization and access control mechanisms, a user logged in as 123 can access the records of another user 456 just by altering the ID. Now, the ID here is called the object or the identifier, and the user record returned by the application will be called a resource. Now, let me explain another important thing called privilege escalation. Now, insecure direct object reference is a type of privilege escalation, but it should never be confused with the broader class of privilege escalation. Let me explain the difference. Privilege escalation usually happens when a malicious user logs into an application as a normal user and then tries to elevate his privilege and perform the actions of a higher role, say for example, perform actions only an admin can do. Now, to add to that, privilege escalation can be classified as horizontal or vertical privilege escalation. Vertical privilege escalation is the one that I explained a few seconds ago, a normal user trying to execute admin commands. Whereas with a horizontal privilege escalation, a user can try and obtain the records of another user at the same level or the same role. This is exactly what happens with insecure direct object reference too. And now you can totally understand what I said when I meant insecure direct object reference is a type of privilege escalation. Let's move on. How do you identify places in the application where an insecure direct object reference can exist? Let me give you a few examples. So you can try an insecure direct object reference in one of the following areas. Value of a parameter used directly to retrieve a record. Value of a parameter used to perform an operation. Value of a parameter used directly to retrieve a file or a resource. Value of a parameter used to access application functionality. Now, let's look at one. So, you see an example URL on the screen. Now, in this URL, you can supply a different value to the parameter invoice, and if the application is vulnerable to insecure direct object reference, it will return the results of another invoice that belongs to another user. Moving on to the next one. So, consider the URL that you see in the screen, where a user tries to change his password. You can simply change the user parameter to another value and change another user's password. See how impactful insecure direct object reference is. This vulnerability can really cause a huge negative impact in the hands of an attacker. Let's move on to 3. So the URL that you see here tries to fetch an image file based on the image parameter. Now the difference between 1 and 3 here is that in the first URL, a database record is returned, whereas in 3, a file from the web server is returned. Anyways, both of these can lead to insecure direct object reference. Moving on to the last type that we have here. Look at the URL now. Guess what the URL does? So it displays a menu item in the front end based on the supplied value, which in our case is 123. An attacker can now play with this ID and make the application display an administrative menu at the front end, which provides an easy way or an entry point to admin functionalities. Okay, one significant thing that you should note with insecure direct object references, it is different from other classes of vulnerability such as SQL injection, cross-site scripting, etc. In that, these other classes of vulnerabilities require a malicious or an abnormal input. Say, for example, SQL injection requires special characters in input. So if you have a parameter named ID and if it takes numeric values, you can supply numeric values 1 to 3 and then supply code, semicolon, double hyphen, etc. to exploit data from the application using an SQL injection vulnerability. Similarly, if there is a date parameter, you can supply a date with additional special characters and operators like union and select commands to exploit the SQL injection vulnerability. And cross-site scripting similarly requires scripts which also involve special characters. However, an insecure direct object reference can happen without a need for special characters or malicious input. It happens just by supplying what we think is a normal, acceptable input but can cause real damage. For example, changing a numeric value from 1 to 3 to 4, 5, 6 or changing a string value from ABC to XYZ can really cause an insecure direct object reference if the application is vulnerable. Let's understand another significant difference with insecure direct object reference. So within application security, most vulnerabilities can be identified using an automated tool, usually called a scanner, and then verified manually or with the help of a proxy tool. However, no tools or scanners exist to identify insecure direct object reference. Now, you can always use proxies to help you with the identification, but there is not really a scanner or an automated tool. Now, the reason for this is tools are limited in that they go with syntax and semantics to identify vulnerabilities. Since insecure direct object reference doesn't require malicious input, there is no way you can apply scanner rules looking just at the syntax. That brings me to another important term used within the space of security, and it is called business logic flaws. So in the security space, business logic flaws are underlying problems in the application that allows to manipulate logic. They can be difficult to find automatically since they typically involve legitimate use of input. However, many business logic errors can exhibit patterns that are similar to implementation and design weaknesses, and insecure direct object reference is one of them. In the upcoming sessions, we will learn how to test for business logic flaws hands-on in specific insecure direct object reference hands-on. So keep watching, hit subscribe to stay updated and receive notifications on our upcoming videos. Thank you.